Now that we've learned the material that we've learned in the previous parts of this lecture, what we're going to do now is look at individual joints and see what kinds of movement you have, what kind of soft tissue you have, and what the bone ends look like. The first group of bones are going to be the vertebrae, C2 through 5. Because remember, the joint between 1 and 2 is that rotary joint. So see, 2 through 5, you have a combination of types of joints. So you have gliding joints at the facets, and then symphysis type joints, so symphyseal joints between the body of the vertebrae. The facets are covered with cartilage and they do glide, so plane movement in a plane, and the discs between the body is what allows for this limited mobility, but it's limited mobility between each of the discs. So when you think of it, your back really does have quite a bit of movement. That's the sum total of all this limited mobility between all the discs. And with regard to the vertebral column, this particular image is good for seeing the ligaments of the vertebral column, and then the next one is good for the actual soft tissue that's between. So if you look at the very top of the image of the picture, you can see that facet, the superior articular facet, and that is the articulation between each of the vertebrae. That's the gliding joint. And then the intervertebral disc is a fibrous cartilage, fibrocartilage, and that has fibers, the annulus fibers, and then you have this nucleus pulposus, which is kind of like a ball bearing in the middle of that, that allows this movement in many directions, but very limited movement in many directions. That's kind of a unique thing about the vertebral disc. And frankly, we would have many problems if we didn't have these vertebral discs. And we also enjoy the fact that we have movement in many directions in the vertebral column. And then you have your shoulder joint. With the shoulder joint, this is ball and socket. You have the acromion and coracoid process. Those are both off the scapula, and they will come in contact with the humerus into the glenoid cavity, and it's the ligaments that are attached between them that help stabilize the joints, that stabilize that shoulder joint. There are muscles that surround the joint. Those are the rotator cuff muscles, and you've probably heard that term, rotator cuff: supraspinatus, infraspinatus, subscapularis, and teres minor. We call them the sits muscles because it spells S-I-T-S, not in that order, but that's what it spells. And then the shoulder also has multiple bursa because of the great amount of movement. So many ligaments, multiple muscles, and many bursa. The one below the acromion, so subacromial, subcoracoid, subdeltoid, and subscapular. And then here's another image of the shoulder with the soft tissue. So you have the humerus taken out here, and so you can see the soft tissue of the shoulder. And by the way, the people who really need to know this stuff, know the portions of the shoulder, are anybody who are planning to code, or you're going into the specifics of a joint. So if you're going to work for an orthopedic person or physical therapy, knowing the minutia of the joints is important, because what happens is they can go in, not me, but maybe you sometime in the future can go in and actually repair parts of this. And so knowing the various parts of a joint become very important for you. But most of the time, although there is a tremendous amount of information to know about a joint, the information is very rational. So you have the acromioclavicular ligament. That's going to be the ligament that goes from the acromion to the clavicle. It just makes sense. Acromioclavicular ligament. Coracoid co-clavicular ligament. So the names are based on where they are, which kind of makes sense to me anyway. The next joint is your elbow joint. This one is a hinge joint. It's very stable. The shoulder was not very stable. Good movement out of the shoulder. Thank goodness, we love our shoulder, but not so stable. The elbow is pretty stable between the humerus and the radius and the ulna. The humerus and the ulna is the larger joint, and that's formed by the trochlea of the humerus and the trochlear notch of the ulna. Now, you find me saying the olecranon process. I actually talk about the positive space. The notch is the negative space, the part that's not there in the ulna. So I wanted to make that clear because I keep talking about the olecranon process and then the fossa. These are two portions on the humerus and ulna that fit together to form this joint. And then you have a humeral radial joint, smaller. It's between the capitulum of the humerus and the head of the radius. And mostly that works to stabilize. It works to stabilize the joint. And then you have the tendons, which there are many in the elbow. This particular I think is kind of interesting because you had, if you were going to create structures that attach to all parts of the bone, so you'd have them with all of these tendons that you see here in the elbow. Then the hip joint, I think this is the last one we look at for the most part. This is the ball and socket joint, and with this, it's also called a coaxial joint. It is circumduction, strong ball and socket, diarthritic joint, wide range of motion. The head of the femur is going to fit into the acetabulum. There you have the acetabulum. And you're going to have numerous ligaments holding this joint together. And you see some of them here. The larger image is anterior and the smaller is posterior. So that whole area, all you're seeing, the whole head of the femur is being enclosed in ligaments. All you're seeing is the greater and lesser trochanter there. Everything else is covered with ligaments, both anterior and posterior. And they each, of course, have they have unique names. Don't get me wrong, but they tend to blend. It's something where you're actually wrapping around that head of the femur on that joint. And then the knee joint, we have the knee joint too. And actually there's a nice picture of the knee joint, and the next picture is a real picture, a picture of person's knee joint. The knee joint is a hinge joint, and you have condyles. Remember the condyles on the femur, and then that articulating with the tibia, and then the fibula coming in. This is the A to P. The next one is a P to A, and with that you again have multiple ligaments, soft tissue. Your quadriceps tendon, which we've talked about quite a bit. You have your patellar ligament here, and between those two, and then the the ligaments on the side for the patella, they regulate the tracking of that patella in the anterior aspect of the knee surface. It's a hinge joint, and it does function to transfer weight from the femur to the tibia in the joint area. Now, these bones don't touch each other. Let me just make that clear again. They don't touch each other. They're actually held away from each other. And let me go to the next one. Just one other thing is you do have this meniscus, which is fibrocartilage again, pad, that will give additional cushion, because this knee there is by definition a lot of weight. This transfer of weight, I mean, it's constantly transferring this weight, and also gives lateral support. The meniscus does. And then here's a oh, it is anterior surface. I'm sorry. This is anterior, and I believe it's either mimicking a real one, or it is a real one. Might be just mimicking a real one, and showing you more of the ligaments, but also basically taking that patella away, and you can see how that tibia articulates with the femur via these condyles. And then what you have is meniscus actually forming the cup that will attach those that will oh, what do I want to say, seal the space between the two. You have lateral and medial meniscus. And then you have the fibula coming in, and what it does, it acts to stabilize that joint. Remember, there is a fibrous joint between the fibula and tibia, between those two. And that's what we have for joints. We will move on to muscles after this. Talk to you later. Bye.